working as an assistant professor at All India Shri Shivaji Memorial Society's Institute of Information Technology. I am going to talk about Isolator. Isolator is a passive, non-reciprocal ferrite device. So as it is a ferrite device, it will use Faraday's rotation principle. Isolator is having following characteristics. It's linear, lossless, passive and two-port device, and which is analogous to diode. That means it allows microwave signal to pass only in one direction. It won't allow any signal reflected or coming from the reverse direction. This is S matrix for the isolator. As you can see, this is for the ideal isolator, which is lossless. So every S parameter, that is S11, S12 and S22, all these are 0, whereas S21, that is input applied at the port 1 and we are considering output at the port 2. So as it is isolated, it provides very less attenuation from port 1 to port 2, and it provides maximum attenuation for the signal coming out of the port 2 to port 1. So that's why we are getting such kind of matrix for the isolator. When isolator is inserted between the generator and the load, the generator is coupled to the load with the zero attenuation and less reflections, if any, come from the load. Load side are completely absorbed by the isolator without affecting the generator output. Hence, generator appears to be matched for all the loads in the presence of the isolator, so that there is no change in frequency and output power due to the variation in the load. Let us see the working of the isolator. So as you can see, it is very much similar to the grater, except that isolator makes use of the 45-degree twisted rectangular waveguide instead of the 90-degree twist in the grater, and 45 Faraday's rotation ferrite rod. A resistive card is placed along the larger dimension of the rectangular waveguide so as to absorb any wave whose plane of the polarization is parallel to the plane of the resistive card. The resistive card does not absorb any waves whose plane of the polarization perpendicular to its own plane. So consider a TE10 wave passing from port 1 through the resistive card and is not attenuated. After coming out of the card, the wave gets shifted by 45 degrees because of the twist in anti-clockwise direction, and then by another 45 degrees is in clockwise direction because of the ferrite rod. Hence, the signal coming out of the port 2 with the same polarization as that of the port 1 without any attenuation. But for a T10 wave, fade from port 2 gets a pass from the resistive card placed near the port 2. Since the plane of the polarization of the wave is perpendicular to the plane of the resistive card, the wave gets rotated by 45 degrees due to the Faraday's rotation in clockwise direction, and further gets rotated by 45 degree in clockwise